Welcome. Today we're going to learn to factor higher degree polynomials, higher degree or higher order polynomials using quadratic patterns. Now, before we do that, I do want to reiterate the difference between the x squared minus 9, or this binomial that's called the difference of two squares. And the reason it's called the difference of two squares is 9 can be represented as 3 squared. This is the sum of two squares. And again, positive x squared 9 could be represented as 3 squared. The main thing I want to emphasize is this can be factored. The difference of two squareds can be factored. The sum cannot. So cannot be factored, at least with nice integers. And what I mean by that is this one can, because I can factor it into an x plus 3 times an x minus 3. Because if you want to remember, I could think of this as x squared plus 0x minus 9, where I'm looking for two numbers that multiply to give me negative 9, but add to give me 0, or no middle term, right? So positive 3 and negative 3 multiply to give you negative 9, but add to give you 0. Again, if we FOIL, x times x is x squared, x times 3 is a negative 3x, 3 times x is a positive 3x, and 3 times negative 3 is a minus 9. These two middle terms, negative 3x and 3x cancel, leaving just the x squared minus 9. This cannot do that. You'll always end up with a middle term, because either both 3's would have to be negative or both 3's would have to be positive in order to give you this positive 9, and so you'll either get a middle term of a positive 6 or a negative 6. This doesn't factor. And I bring that up because we're going to see this in the future in this lesson. Now, the next thing I want to talk about is, remember how we factor polynomials. If I gave you this polynomial right here, x squared plus 8x minus 48, what you do is you take that negative 48 that's on the end. We're going to look at factors of that, like negative, negative 1 and positive 48, negative 2 and positive 24, negative 3 and positive 16, negative 4 and positive 12, negative 6 and positive 8. And we get these factors. And the reason I made the smaller one negative and the larger one positive is because when I add the two factors together, I want it to equal a sum of 8. But I want the product to be negative. That's why I made one negative and one positive. Well, let's look down and see when we find a positive 8 sum. So these two multiply to give me the negative 48, but do not add to 8. These two, again, do not add to 8, but they do multiply to give you negative 48. These two do not add to 8. These two add to 8, negative 4 and positive 12. So this would factor into an x minus 4 and an x plus 12. Okay, that's the factoring process that we learned in the previous lesson. Now, in this lesson, we're going to be given, now I don't want to slide down yet because I want to show you that this expression looks very similar to this expression. The only difference is I have higher x's, or higher exponents on the x's, right? Now, what I need you to remember is that I can take, let's say I take that x to the 4th. I could write that as x squared raised to the 2 power. Because what's x squared squared? Well, those two multiply and give me 2. Or sorry, give me 4, not 2. Give me 4. 2 times 2 is 4. So what you do, this whole lesson, this factoring higher degree polynomials using a quadratic pattern, it's you want to take this and you want to think of this as not a 4th power polynomial, but as a quadratic. And you're like, well, how do we think of it as a quadratic? What you're going to do is you're going to write it as x squared in parentheses squared plus 8 times x squared minus 48. Now, this is like an x squared. This is a single x in parentheses. It's an x squared, don't get me wrong. But so what I'm going to do is I'm going to factor it just like I did this one up here, except instead of an x and an x, I'm putting an x squared. So I'm going to factor this to an x squared, parentheses, x squared. And then again, two numbers that multiply to give you negative 48, but add to give 8, were that 4 and positive 12. So I do a minus 4 and a plus 12. So I factored this higher order polynomial as if it was a quadratic. But now you need to be careful. Oftentimes, when you do these type of higher order polynomials, one of the binomials ends up being a difference of two squares, like I talked about at the very beginning with this x squared minus 9. So it can factor further. This x squared minus 4 can factor into an x plus 2 and an x minus 2. Now this is a plus as well. This is not a perfect square, so this does not factor any further. I leave it as an x squared plus 12. And there's my completely factored form of a higher polynomial because I thought of it as a quadratic, an x squared that's being squared. Now, this will take some practice, but it's always looking at these exponents. Now, if these exponents, by the way, aren't even, it wouldn't work because you wouldn't be able to square it. If I gave you x to the third plus 8x squared minus 48, I would not be able to make that into a quadratic because 3 isn't even. Right? I couldn't write it as x squared raised to the, what would I raise it to? I don't know what, I mean, it would be a fraction, 3/2, but that's not even a quadratic, so that doesn't work. So let's do another example very quickly here, so I don't spend too much time. Let's do this one right here. This x squared, or x to the fourth, minus 18x squared plus 81. Well, the first thing I'm going to do is I'm going to write that as an x squared in parentheses squared minus 18, and then I'm going to put in parentheses x squared plus 81. Now again, I want to see, okay, I have an x squared that's squared. So that tells me, and by the way, this has to also be an x squared. If it was a single x, it wouldn't work. I want to emphasize that. This has to be an x squared. So we have an x squared in both parentheses. But I'm going to put an x squared here. I'm going to put an x squared here. And now I'm going to think of two numbers that multiply to give me a positive 81, but add to give you negative 18. Well, hopefully you guys can see that right off the bat. It's a negative 9 and a negative 9. So I'm going to put a minus 9, and I'm going to put a minus 9. Now, again, if you need to FOIL that out to see that that actually equals this, you may do that. And in fact, you get the actual original equation of x to the fourth up here, and an x squared. But again, these are the difference of two squares, right? So I can actually factor those even further. I can factor this into an x squared, not an x squared, sorry, just an x plus 3 times an x minus 3. And then this one factors into an x plus 3, x minus 3. Now, they might actually write this a little shorter because if you'll notice, I have two of these x plus 3s. So you could actually technically write that as an x plus 3 in parentheses squared times, and again, I have two of the x minus 3s, x minus 3 squared. And that would be the factored form of that original higher order polynomial that we had up here, wherever it went. Oh, I'm hiding it right there. This x to the fourth minus 18x squared plus 81 factored into the x plus 3 squared times the x minus 3 squared. If you have questions, bring them to class.